Hello, everybody, and good morning.
Hi, I'm Catherine Havasi. I'm CEO and co-founder of Luminoso. So I'm here this morning to do a little bit of overview about artificial intelligence, especially natural language understanding, moving to a type of technology that makes these new advances more accessible, called transfer learning, and then talk a little bit about what my company, Luminoso, does. All right, thanks. Excellent. Now we seem to have gotten everything under control. Let's get going. All right, so to kick off this morning, I know we've all been talking a lot about data and artificial intelligence, but we're really at the cusp of a lot of innovation around AI that's really seeming to be making an impact. So especially around computer language understanding. We've seen with the intelligent agents that have come out right now, both an appetite and an ability for computers to more deeply understand us, both when we talk to each other and when we talk to machines. This is really going to enable a lot of different technologies moving forward, and it's really quite exciting. There have been a really huge leap forward in natural language understanding technology over the past couple of years. This is called word embeddings. I'll dive in a little bit deeper. But first, it's important to note that artificial intelligence in general is really increasing here in Japan. We can see that with the room, the standing room only here today, but also with the companies that we see that are in the different booth sessions everywhere. There's just a lot of interest in artificial intelligence. So, and with that interest comes a lot of interest around things like deep learning. I think we've all seen the ability for deep learning to really have an impact on business and its power with things like AlphaGo and with other big feats of AI that we've seen recently. For those of you who are still curious, deep learning is the ability to take the human ability to understand patterns in data and bring that to its next biggest logical extension. So deep learning finds the patterns in an input data, how they react to each other, interweaves them together, and sort of pushes this out to a greater extreme. Deep learning for language is often something called word embeddings, a type of technology that was popularized by Google in 2013 with something called word-to-vec. And a lot of people really want to know, is this type of technology going to open up language understanding at a deeper level? There are a couple of problems with things like word-to-vec, regular word embeddings technologies. First of all, we're all here in Japan. They're very English-centric. If you look at Glove, if you look at word-to-vec, they all come out English, and it's taken a long time for embeddings from the major US tech players to start working in Japanese, and that's a problem. Also, they're not adaptable. It takes a lot of compute and a lot of time to rebuild the models. Additionally, there's a lot of issues around bias, especially algorithmic risk in some of these existing models. That becomes an issue. They're not very explainable sometimes. Why did the computer make the choices it made? That can be very difficult to understand. And also they have difficulty adapting in real time. And the reason for this is that every time they learn new information, they have to start from scratch. They have to learn everything from the ground up each time they learn, and that's not how people work. It also has an enormous amount of data required to do this, often hundreds of millions or billions of data points. That provides a barrier to entry for almost all enterprise that is not web scale, but rather enterprise scale. If you think about an individual product a company would have, they don't have that much information about that individual product from customer feedback or from internal documents to be able to understand the nuances of the technical language around it. And again, this is because what we have here is something that has to learn from the ground up each time that it learns. That's not how people work. So if you can imagine, if you're designing a new chocolate bar or a new confectionery, the amount of specialized language to talk about the
chocolate and to talk about the taste of the chocolate. Experts, somebody who's a professional chocolate taster, would have one vocabulary. Somebody off the street would have another vocabulary. But to actually understand the differences and the way these things relate to each other, you're going to need a model that's specialized to chocolate. If you think about it, there are words that mean good things in some contexts and bad things in another context. It's all about the context, and understanding that becomes very critical. But to go back to the chocolate example, there's no way you get enough data to train a deep learning system about chocolate specifically. It would just be too difficult. And if we take that problem and we sort of expand it outward, we find that what we're ending up with is a much deeper problem for verticals with more technical language. So verticals like consumer finance or healthcare or even government, where there's a lot of very specific words that are used that have very different meanings for that context. And it becomes very difficult to use a domain general model in a domain-specific setting. Transfer learning is the process of taking a domain-specific model and moving that into a domain general model, and moving that into a domain-specific context, such as taking something like Word2Vec and making it work for something like healthcare. We've seen a lot of interest in transfer learning as an emerging technology. Many big players in the field have talked about the importance of transfer learning to commercial success for AI. Most of you have actually used this. If you used an app on your phone that made it look like a picture that you took outside was painted by a famous painter, using that kind of technology is transfer learning. And it's used frequently on the internet for funny things. For example, this is an image that a model that was trained on books of flowers asked to reconstruct a book full of dinosaurs. You get dinosaurs full of flowers. It's very interesting. But again, you can see, how is this actually applied to the enterprise? How can we make better things than pretty pictures? One place that we're thinking about applying this right now is in self-driving cars. It would be very difficult to go out there and get actual self-driving car data in many scenarios, some of which are too dangerous, and often there are just too many scenarios. So people are exploring using a simulation and using transfer learning to the real car, or being able to use maybe a smaller car. I've seen people do this, trying to do this with model cars and model tracks and moving them forward. So being able to transfer from a difficult domain or a dangerous domain into a domain that's easier to model. Additionally, we've seen this work with languages. I'll talk a little bit more about this later. Both with the languages that have less resources out there, i.e. languages that aren't English, taking a model that was created for English, moving it over to that language. And this can happen inside a contact center or a customer care situation where someone who has built a model in one language and wishes to make it work in many different languages. We've started to see some pretty interesting and exciting and a little scary applications of transfer learning in both voice and video, where we see it being able to build a model of someone's voice well enough that it can make it sound like somebody said something that they didn't say by transferring from one voice into another voice. And we are starting to see preliminary academic work in doing the same sorts of things with video. That opens a lot of questions, most of which I'd be happy to talk about, but are for a different talk. What I'm very interested in is, how does this apply to business, and how have we seen applications of this in the enterprise? As you probably guessed, I do natural language processing and transfer learning at my company, and so we have a little bit of an idea of how this sort of thing has come to play. So right now, companies are very interested in deep questions that they can get from consumer data. So this is things like, what is causing churn in my company? What is causing more sales conversions? But also questions like, how are consumer buying patterns changing with IoT? How are various different things changing? Being able to get this kind of information requires something much deeper than sentiment analysis, which can really say this is positive or this is negative. Often questions that have actionable business outcomes require more depth. So to give an example, we were working with a consumer goods company that was building a men's toiletry product and the marketing and packaging around it. So when they did customer surveys, they asked, does color affect the way that you buy toiletry products? And all the consumers said no. None of them said color was important to them. But it was fairly clear to this company that that was probably true. So what they were able to do was go out and collect more data. But the amount of data that you would need to collect to actually understand the way people talk differently when they are passionate about a product is quite large. So what you would need to do is do some transfer learning from the general domain into the domain of toiletry products, which it sounds really exciting, but actually is very exciting for the business. So what you end up doing is taking these products into the homes of consumers for about 2 weeks, calling them up, seeing what they had to say about the product, and then saying, can we predict, can we do anticipatory analytics about the buying patterns afterwards from the way they talked about the product? And the answer is yes. Not only do consumers talk more excitedly about more brightly colored products, but that also predicted their buying behavior later on, whether or not they use the more brightly colored product. There was more attachment to the more brightly colored product, and people got very excited. So the company was able to prove this and went out and changed the packaging and coloration on several of their products out there, especially razors and shampoo, and those became the best-selling products for them in that line. So very much important that we understand the nuances of the way customers talk in this particular domain. A flip side of this that's particularly fun and interesting is mobile gaming. Now, my company does a lot of work in consumer electronics and software and telecom, sort of the mobile ecosystem, but consumer gaming is really a new peak of very domain-specific language. It's up there sort of with consumer finance or healthcare. Because if you think about it, each time somebody releases a game, there's so many specific words to the game, you know, ice wizards, various different kinds of meta, things like that. I don't even know, but there's a whole lot of different, very specific language, and that language changes very quickly. As these games come out and have new releases, new stuff is added, and they need to be able to understand that. For this company, which is one of the biggest mobile gaming companies, they needed to be able to process that customer feedback as it comes in, figure out who needs to be sent to a self-help article, and who should actually talk to an agent, and which cases are likely to have a risk of fraud. So they are watching these tickets come in, they're having a model that adopts to their domain, understands the language of the games, and says, look, these words are indicative of someone who plays the game a lot. These words are indicative, these concepts are indicative of someone who maybe doesn't play the game as often, and now we can route accordingly. And using this technology, they were able to, cut costs dramatically and push additional 40 to 50% of calls out of their contact center into self-help. So that was a pretty dramatic reduction in costs for them. So I've talked a little bit about us. Who are we? We're Luminoso. We're based in Cambridge, Massachusetts, although we have sales offices in other places ranging from Sydney to London. We help companies process their customer feedback data using advanced natural language processing. We see more and more companies are getting contacted in many different channels from folks who are interested in reaching out to the company, either because there's a problem, because they have additional questions, or sometimes in a sales capacity, we're starting to see companies reaching out to customers, so the reverse of that. But it's driving a lot of traffic into these companies. And what's surprising is, globally, more people are contacting brands than they were even 5 years ago. We think maybe in this age, we're more likely to just Google to get the answer, but no, what's going on right now, people are reaching out, people have questions, people want to engage brands. And so we help companies handle that by taking that information and both using it to optimize and automate, as well as being able to pull deep analytics out of it that companies can use to affect their bottom line and make action based on the insights that they get. We typically work in a couple of different verticals. As I said, we worked a lot in consumer electronics ecosystem, mobile, telecom. We also work with consumer packaged goods as is obvious from my case study, and retail. Lately, we've been doing a lot of work in consumer finance, both globally, as well as starting to do work in healthcare. So any vertical where there's a lot of customer feedback and a lot of very specific languages. As I said, in the contact center, we can really make an impact beyond just diverting people to self-help to cut costs. We can also do things like understand why people are calling a company and how sort of a phone tree should be set up with the same level of accuracy as consulting-based approaches. In language processing right now, both here in Japan and globally, there are a lot of companies that build very bespoke solutions. They come in, they build things very individually for each company. That can be very expensive, it can be hard to maintain, it can frankly not work as well. We automate that process. In doing that for the contact center, we're able to duplicate the results of these consultant-driven, machine learning consultant hybrid approaches with 80 to 90% accuracy in 15 minutes instead of in months worth of a process. So it really changes the dynamic. We do this because we've actually been working with language for a long time. We work with a knowledge graph called ConceptNet that we started building at the MIT Media Lab in the late 90s. So ConceptNet also, as some people might know, is in Japanese as well and has a partnership. ConceptNet has a partnership with Dentsu and Unisys, as well as Hokkaido University, to build a large knowledge graph in Japanese that we've been building for years to be able to understand the connections and meanings between words. That allows us to really build a great base model, plus our machine learning algorithms, to be able to transfer what looks like a deep learning model into a domain without the data for it. Although this is emerging technology, we've been using this for years to be able to help companies better understand market feedback. And ours is very accurate. We won the global benchmark SEMAVAL this year, as well as several other global benchmarks. So we are currently the highest benchmarked natural language processing company across most languages. And we're so accurate that we can beat Facebook's deep learning model in Spanish without ever training in Spanish. So we have a lot of power in multilingual models. We're really excited to be here in Japan and to speak with you. We already have Japanese investors and customers, as well as partners who don't have to speak to you in English. And we'd love to talk to you to see whether or not this is either a good partnership between us, whether or not this is something your company might want to try, or whether or not this is something that you might want to learn more about from a technology perspective. So we're really happy to talk to you. We're going to be here this week, as well as running a seminar on Thursday. I hope you come by with your questions about both transfer learning, language understanding, and AI. And if you want to talk to us and don't manage to grab me after the session, please do come by and chat. All right, thank you.
Hi, thank you for the inspiring presentation. I want you to kind of walk us through on the example you gave us on men's poetry example
Yes.
you gave us. And I was interested in how you have made connection between people's excitement on the color variation. But can you kind of walk us through step by step how it was done and how many data points you were it was necessary to?
Absolutely, yeah. So this particular example was a grooming product, and we're looking at something for shaving. And so the first thing that they did was they went out and got customer panels. I think they had roughly, I would say, 50 customers that used 50 or 60 customers that used one of 3 different product prototypes. And they gave consumers those product prototypes and had them use them for about 2 weeks. And then they called them on the phone, and they actually took voice. We do speech to text if the stuff is in voice as well. And what ended up happening was we got about, I would say, 60 data points of people talking for about, I would say, roughly 5 minutes about their experience using the product. They answered a couple of different questions. They answered a question about, what they thought of the product. They answered a question about what they noticed about the product. And I think they answered a question about whether or not they would buy it again. And that data came into our system. So at that point, the system reads it and builds a domain model for it, but it does all this automatically. So the domain model takes that data in and runs probably in about 3 minutes to build the domain model, and then we'll come up into our Explorer visualizer. So we have 2 products. At that point in time, you can both see what's attached to different things. So it integrates structured data as well. And at this point, they were looking at which were the colorful product prototypes and which weren't, and we're able to look and see what the differences in language were from there. So hopefully that gives you a good answer. We typically work with, depending on the data richness, a couple hundred to a couple thousand data points in something like a call center.
Just to quickly follow up. So obviously consumers wouldn't tell you that this color is exciting.
You're right.
Yes. So I'm assuming that you have like a word library that kind of attaches emotion to the.
Yep. And that's one of the things. I think this particular case, they were very much looking for excitement as an emotion. Emotion isn't just positive and negative, especially on the negative side. I think every happy consumer there's a lot of similarities between happy consumers and vast differences between unhappy consumers because, disappointment is different than anger. Very, very different. And that kind of stuff. But also it's not just about emotion, it's also about things like, I wanted, in this case it was very emotional, but in the gaming case, that's not always emotion. It's more like this person is simply complaining that they don't get enough legendary cards and don't want to pay for them. So maybe we should send them a fixed message, rather than have them talk to an agent, or this person is potentially experiencing fraud and someone hacking their account. We need to elevate this. So there's a lot more concreteness. It can be emotional, but not super concrete.
Thank you.
Your turn.
Okay.
All right. Thank you so much.